Hello and welcome to your functional skills lecture on learning outcome 1 and learning outcome 9. In this lecture we are going to read, write, order and compare positive and negative numbers of any size and order and approximate and compare decimals. Now your objectives for this lesson are a little bit more in depth. You are going to be able to write numbers in order using place value, add, subtract, multiply and divide negative numbers and positive numbers of positive and negative size, and write square numbers and cube numbers as well as their roots. Okay, so hopefully we can get through quite a bit and you can understand the majority of the lesson today. Okay, first of all then we are going to look at positive and negative numbers. And we're going to look at place value. So some people get a bit confused with place value. Place value is just understanding what the numbers mean depending on where they are in a certain number. So each digit in a number has a place value. The value of the digit depends on its place in the number. The place value changes by a factor of 10 as you move from one column to the next. Okay, if we look at this example in the place value chart, we can see that we have some numbers written underneath what they represent. So this is the 10,000s column, this is the thousands column, this is the hundreds column, this is the tens column, and this is the units column. So we write this number, or we would read this number as 74,000. We have 7 lots of 10,000, so that's like 70,000. Okay. We have 4 lots of 1,000. So that's 4,000. We have 1 lot of 100. We have 3 lots of 10, which is 30, and 2 ones, which is 2. You read this number 74,132. Okay. So instead of saying 70,000, 4,000, we would just say 74,132. Okay, so what I'd like you to do is I'm going to give you 3 numbers and I'd like you to write them in words and then give the value of the underlined digit. So, for example, here are your 3 numbers. I'd like you to write them in words first to give yourself practice, and then if I go back to our previous slide, let's say I underlined the number 4 here, okay. That 4 has a value of 4,000 because it's in the thousands column. Okay, any number on the end is always the units. The number next to it is always the tens, and then the hundreds, then the thousands, and then the tens of thousands. If we had another number here, okay, let's say I put like an 8 there, that would actually be the thousands. Okay, so we just go. Every time we go up, it increases by a factor of 10. We add on another 0 to the value of that number. So here are your numbers. Why don't you pause the video and just have a go at writing those in words and then writing the value of the digit underneath, and press play for the answers. Okay, if you've had a go at those 3 numbers, let's have a look at the answers. I've written them below. So for A, your answer should be 538, and the digit 5 represents 500 because remember we have our units first at the end, and then the next one along is tens, and then the next one along is hundreds. So that H, that 5, is 500. Okay. For B, it's 2,371. Okay, and the digit 7 represents 7 tens or 70. So again, units on the end, then your tens, then your hundreds, then your thousands. For your thousands, you can write a T and then a small h, just so you don't get confused with the tens. And 7 is in the tens column, so it actually represents on its own 70. If we didn't have the 1 on the end or whatever, that 7 represents 70, 7 tens, okay? And then finally, this last one, probably a little bit harder because we haven't actually looked all that way. But we've got units on the end, then you've got your tens, then your hundreds. We've then got our thousands, okay, and then this one is our tens of thousands. And this one is our hundreds of thousands. And then we have got our millions, okay? So, now, it's easy to read out a number if you make sure. So if I wrote this number out like this, you might think, oh, how would I even say that? So to make it easy for yourself, we put in a comma every 3 digits back. So we go back 3 and we put in a comma. And then we go back another 3 and we put in a comma. And it ends up looking like this. And then we can see, okay, now I understand my tens, units, whatever. And I have 6,352,740. Okay. So your 5 here actually represents 5 lots of 10,000, okay, which is 50,000. 5 lots of 10,000 equals 50,000. So that's what it would be on its own. That's what that 5 represents. Okay, so I hope you did well on those. All right, let's move on. Okay, so looking at our place value chart again, if we look at this number here, 74132, which is 74,132. 74,132, okay? Now, as you can see, I've put my units on the end, which is where they should be. And anything before the units increases in value, it gets bigger, okay? Now, if I inserted a decimal point, so I've done another chart here, all right, still got the same units, okay, but this time I've introduced a decimal point after that, and anything after the decimal point going that way decreases in value, it gets smaller, okay? So anything before the decimal increases as we go up in place value, and anything after the decimal point decreases in place value. All right, it's really important to remember that. Okay, so the reason you need to know that is because you need to be able to order numbers. So I just want to explain that everything after the decimal point has also got a label. So how we had units, tens, hundreds, thousands, and 10,000s when the numbers got bigger, when the numbers get smaller after the decimal point, we say that they are tenths. So this 5 would be tenths, okay, after the decimal point. This 3 would represent hundredths, okay, that's 2 digits down, and then thousandths, and then tens of thousands, sorry, 10,000ths, okay. So we need to make sure that we remember that these are getting gradually smaller as we go along. Now, the number 2.5324 means that you've got 2 whole ones, and then you've got 0.5324 of a whole one. You've got 2 whole ones, and then you've got a part of another whole one. Okay, so we need to remember that that is part of a whole. It's a fraction of a whole amount. Okay, now when we're ordering numbers, we need to remember that this is bigger than this. Okay, and we're getting smaller as we go down. It's very important that you remember when you go down, you're getting smaller after the decimal point. If we look at some examples, if we had the number 2.53 and then we had the number 2.034, I know that this is the smaller number because the tenths column is smaller for that number. It's a 0, whereas this one's a 5. Okay, we must remember that. Okay, if I had a number 2.53 and 2.57, then I know this is smaller because it's a 3 and the other one's a 7. Okay, another example could be something like 4.602 and 4.6024. Okay, this one is actually now the bigger one. Okay, it looks bigger, but also this one hasn't got a 10,000ths digit, so it would technically be 0. So we can see that it is smaller than this one, which has got a 10,000ths digit, which is 4. Okay, what I want you to do now is I want you to have a look at this slide, pause the video, and try and put these into order of size, starting with the smallest, and then press play for the answer. Okay, if you have had a go at these this question and try to put them in order of size, the first thing I would do is look at first of all, you can look at the units. The units are all 0 for all of them, so that's fine. Now, let's look at the next one. I'm just going to change the colour of my pen. The next one along after the decimal point is the tenths. This one is a 0. Okay, so that's really small. All right, this one is a 7, this one's an 8, and this one's a 7. Okay, so I know straight away that this is my smallest number. I'm going to write that down here, 0.078. Okay, I'm then going to go back and look again at my my second digits. My first digit after the decimal point, should I say. So I've used this one, I don't need it anymore. This one's a 7, this one's an 8, this one's a 7. So ignoring the 8 for now, because I know that's going to be my biggest one, let's look at this number and this number. Okay, I have 0.78 and I have 0.70. Okay, we can ignore that one on the end for now because I already know that this 0 is smaller than this 8. Those hundredths digits, which is this column here, okay, those hundredth digits are comparable. 0.708 is smaller than 0.78, okay? So I've done my first one, 0.078, and then 0.708 or 08, and 0.78. Can we see how these are all ordered, smallest to biggest, and then these are also ordered smallest to biggest. Obviously, I know 0 here is smaller than 7, but because this 0 is smaller than this 7, this is still smaller. Okay, and then finally we've got our 0.87, which is obviously the biggest one because it's an 8 in the 10th column. Okay, all right, I hope you understood that. We're going to move on now from ordering decimals, but there will be some examples in your assignment for you to have a go at. All right, let's have a look then at ordering positive and negative integers. So integers are positive or negative whole numbers. Okay, they are whole numbers. We're not looking at decimals anymore. An integer is a whole number. Numbers that are positive are above 0, and negative numbers are below 0, which I'm sure you already know. Integers are directed numbers, okay? That's because they have a direction. They are either positive or negative, as well as a size, okay? So an integer could be 5. That's a positive 5. It's either positive or negative, and it has a size. It's 5. A number without a negative sign is positive. So if we don't write a negative sign, we know it's positive. I'm going to let you pause the video again, and I want you to put these positive integers in order of size, starting with the smallest. I'm sure you can do that relatively easily. If you are confused, remember you can write your units, tens, and so on. Units, tens, hundreds. Units, tens, hundreds. You can go back and look at the place value chart that we looked at previously. Units, tens, hundreds, thousands. Okay? And you'll be able to see which ones are bigger and which ones are smaller. Pause the video and then I'll put the answers on. Okay, if you've had a go, here are your answers. Now it's quite obvious that these are starting from the smallest and going up to the biggest. We have here 5 units. We have here 2 tens and 6 units. 3 tens and 2 units. So you can see they're going up. 26, 32, 85, 114, 502, 794, 3,297, 4,209, 4,351. I'll just draw your attention to these two numbers because they're both 4,000. Okay, both 4,000. But this one's 209, whereas this one's 351. So we know this is smaller than this one. Okay, I'm sure you're fine with writing numbers in order of size, but we then here have 54,321 and then 745,908. Okay, so well done if you got all those right. Let's have a look at some negative numbers now, which is where people seem to struggle quite a bit. So again, if you would like to, you can pause the video and have a go at this task and press play for the answer/explanation. Okay, if you've done that, let's have a quick look at what negative numbers actually mean. So we have 0. Here's 0, look, just there in the middle. Anything before 0 gets smaller. Okay, and anything after 0 gets bigger. Okay, so if it was 0 degrees outside, okay, it's quite cold, but if it's -9 degrees, that's really cold, that's a lot colder, that's smaller. You could also think of it like money. If you had £0 in the bank, that's bad enough, but let's say you borrowed money from the bank and you owe them £9. Okay, you're at -9, you're at £9 overdrawn in your bank. That's, you owe more money, okay, and that means you've got less of it. You've got less money because you already owe the bank £9, all right? So, if we're going to put these numbers in order of size starting with the smallest, the biggest negative number is the smallest one. Okay, so the -6 will be the smallest one. And then just a little bit bigger than -6 will be -5. Okay, I'm going to just write those out just there. Okay, so we've got -6 just there, -5 or -5. We've then got the 0, so we've done that one, done that one, done that one. And then after that, after 0, after that, you will then know which ones are bigger. So you know that we've got 6, 8, and 12. All right, so when we're writing negative numbers, it's the largest negative is actually the smallest number. Okay, think of it like it's -6 degrees outside, so it's really cold. And then later on it's -5, so it's still cold, but not quite as cold. And then 0, still cold, but not quite as cold as -5. Then it gets to 6, then to 8, and then to 12 degrees. Okay, so 12 degrees is manageable-ish. Okay? If you're like me and like the heat, then 12 degrees is not manageable. All right, so that's how you are going to order negative numbers. Okay, so moving on again, we're just going to quickly recap the symbols for greater than and less than. Okay, so we will look at these again further on in the course, but we've got to remember that greater than is this symbol. Okay, so we're going to say which one is greater than and which one is less than. Okay, less than is that way. All right, again, if you'd like to pause the video and have a go, please do, and then I'm going to put up the answers. So, can you put the correct symbol in the boxes for each pair of numbers? Is -5 greater than or less than -2? Is -4 greater than or less than -6? And is 5 greater than or less than -2? Okay. All right, if you pause the video and had a go, here are your answers. So -5 is actually less than -2 because it's colder. Okay, remember what I said, the greater negative is actually smaller. -4 is greater than -6. If we look at this on our chart, here's -6, and I told you that if we go this way, it actually increases in value, it gets bigger, and -4 is here. So -4 is bigger than, or greater than, -6, because it's a bit warmer, all right? Or you owe less money to the bank. Okay, and then 5 is greater than -2. Okay, we already know that anyway, because if you've got £5, you're better off than if you owe the bank minus £2. Or if it's 5 degrees outside, it's better than it being minus 2. Okay? All right, another couple that you could just remember is greater than or equal to. Again, we are going to go over these again. Okay, and that's just the greater than symbol with a little equals sign underneath. And then less than or equal to is the less than sign with a little equals underneath. Okay, we're going to cover these when we do inequalities. Okay, so for now, I hope that was a good recap. Let's move on again. Okay, now we've got to go through some rules now for adding and subtracting negative numbers. It can be very difficult to remember these. So when we're adding and subtracting negative numbers, it's a little bit different to when we're multiplying and dividing negative numbers, okay? So you must remember that when the number to be added is negative, the normal direction of movement is reversed, okay? So if we're saying, for example, question A, minus 2 minus 3, okay, you're technically doing minus 2 and you're taking away 3, you're going back 3, you're reversing it. You're not adding 3, okay? And the same for question B. Even though it says minus 3 add minus 6, you're adding a negative. So you would start at minus 3 and you would actually add a minus 6. You go back 6, 4, 5, 6, okay? Now, however, another thing that you need to remember is that if we look at example C, you've got two signs in the middle that are the same. So when they're in the middle that are the same, we turn it into an add. Okay. Now, if it was 5 plus 2, which you wouldn't really get, it would just stay as an add because you're saying 5 add positive 2. Okay. However, if they're two negatives, we actually join them together to create an add. So that would become 5 plus 2. Okay. Very important to remember that. All right, so another example just here. If we had minus 4 minus 3, this would still turn into an add and we would end up with minus 4 plus 3. Okay, and if I change my pen again, minus 4 plus 3, well, when we add, we go that way. Okay, so it's 1, 2, 3, leaving us with minus 1. Okay, so just be very careful with those ones in the middle. Okay, and you must remember when we add, we go that way, and when we take away, we go that way. All right. So when two signs are together, these rules are used. So here we have add and add, which are next to each other, like I explained here. Okay, that just continues to be an add. Take away and a take away, like here, or a negative and a negative, we turn it into an add. Okay. And then when they are different, they're always subtraction. Okay. So if I had 4 plus minus 3, this wins. It's just 4 minus 3. If I had 4 minus plus 3, again, this wins. It would be 4 minus 3. Okay, they're the rules. So let's just recap that one more time. If your signs in the middle are the same, okay, can you see here? These two. If they're the same in the middle, it's always an add. All right, if these two are the same, if we look at example C, if the signs in the middle are the same, it's an add. If the signs in the middle are the same, it's an add. If the signs in the middle are different, we just do it as a subtraction. We take away. All right. Okay, why don't you pause the video and have a go at those questions and I'll put the answers up. Okay, if you have had a go, if you've paused the video and had a go, I'm just going to show you the answers now. So, minus 2 minus 3 would be minus 5. Let me use the number line to show you. Minus 2 minus 3. That means we're at minus 2 and we're taking away 3. Remember, when we take away, we go that way. 1, 2, 3, and we end up at minus 5. Okay? Minus 3 plus minus 6. Well, if we look at our rules, the signs in the middle are different, so we just take away. Okay, if the signs in the middle are different, we take away. All right, so we are at minus 3, because that's what's here, and we're going to take away 6. All right, and again, take away is that way. So 1, 2, 3, 4, 5, 6. So that would be minus 9. Okay. Question C. The signs in the middle are the same. So that becomes an add. 5 add 2. That's a nice easy one. 5 add 2 is 7. Okay, and then you've got question D. Now, question D, you could turn that around and do 8 minus 15, because it means the same thing. Positive 8, which we've got here, minus 15. So I've switched it around just so that I can show you on the number line. Now, you could do minus 15 and then count back 8 places. Okay, so if I did that, it would be starting at minus 15, minus 14, minus 13, minus 12, minus 11, minus 10, minus 9, minus 8, minus 7. Okay, so my answer should be minus 7. All right, I've counted back 8 times. But I'm just going to show you this on the number line. Let's use blue. Because I've switched around the question, I'm calling it 8 minus 15. Here's 8. And I'm going to take away 15. And if I take away, it's that way. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And it gives us minus 7. Okay, minus 7. So I know I'm right either way that I've done that question. Okay, so you can switch it around and do the positive, take away, well, yeah, take away the 15, minus the 15, okay? And your answer will give you minus 7. I'm just going to rub that out so I can put the answer on. Okay, minus 7. Okay, so next we've got question E, minus 8 plus 6. So I'm just going to rub out now some of this because we're going to start getting a bit confused. And minus 8 plus 6. Well, here's minus 8. And we're going to add 6. And we know we've got to go that way for plus 6. So it's 1, 2, 3, 4, 5, 6. Giving us minus 2. Nice and easy. And then the last one is minus 3 plus 6. So if we're here at minus 3, and again, we're adding 6, going that way. 1, 2, 3, 4, 5, 6. Giving us an answer of 3. All right. So I hope that was a bit more understandable. Make sure you remember the rules for the values that are in the middle of the numbers. So like if we had 8 plus minus 6 or 7 minus plus 4. Okay, these would always be a subtraction because the numbers are, because the signs are different. But if it was the same, so we had 8 plus 6, then it would just remain a plus. And if it was 7 minus 4, then it would turn into a plus. Okay, so be very careful. Make sure you revise those. Let's move on one more time. Okay, so what we're going to do now is looking at multiplying and dividing negatives. Now, in my opinion, this is easier. So when you multiply and divide negative numbers, you can do it as if they were just normal positive integers, normal positive numbers, and then find the sign for the answer using the rules. Okay, so for example, in fact, just ignore that for a second. Let's look at this box down here that I've put in. So a little bit similar to the addition, but not as long-winded, not as difficult. If you're multiplying two negative numbers, okay, so let's say a negative 4 times a negative 2, your answer will be positive. Okay, so we'll do the calculation. 4 times 2, which is 8. And because I know that they're both negative, it will be a positive 8. Okay, it will be positive. If I multiplied two positive numbers together, like 4 times 2, my answer will also be positive. Okay, so if they're the same, okay, can you see that? And that is the same. It's supposed to be. I don't know why my negatives have gone a bit funny there, but they're supposed to be both negatives. If they're the same, you get a positive answer. The same here. Both are positive, so you get a positive answer. They're both the same. However, if you are multiplying a negative, such as -4 times a positive, your answer will be negative. So if your signs are different, okay, this is a negative, but this is a positive. So your signs are different. So I'm going to do the calculation, 4 times 2, but because one of them is negative, it will be a negative answer. The same if I did 4 times -2. 4 times 2 is 8, but it would be a negative answer because the signs are different. Okay? So if the signs are the same, you get a positive answer. You would write the answer as positive, and if the signs are different, you would write the answer as negative. Okay? Here are 4 questions. I'd like to pause the video and have a quick go at those, and then press play for the answers. This doesn't matter if it's multiply or divide, the same rules apply. Okay, have a go at that. Okay, if you've had a go, then let's go through the answers. For question A, the signs are different. Okay, I'm just going to write here, same equals plus, different equals negative. For A, the signs are different. So let's do our calculation. 6 times 3. 6 times 3 is 18. But because the signs are different, one is negative and one's positive, my answer will be negative. So it'll be -18. For question B, you've got -4 or -4 times negative or -2. Okay, the signs are the same here. You've got a -4 and a -2. They're the same. 4 times 2 is 8. And because the signs are the same, it's a positive answer. So we just leave it as 8. For question C, you've got a -20 divided by a -2. The signs are the same. 20 divided by 2 is 10. And I don't need to add a sign because they're the same. So I know my answer will be positive. And then the last one, 9 divided by -3, they are different. You've got a positive 9, you're dividing it by a -3. 9 divided by 3 is 3, but because the signs are different, the answer will be negative. Okay, and that's all you really need to know, because you need to just make sure that you're understanding these rules and can answer those simple questions. Okay. Obviously, it might come up within certain problem-solving GCSE questions, but as long as you know the rules, then you'll be fine. Okay, so now we're going to just quickly look at square and cube numbers. So square numbers are whole numbers that are raised to the power of 2. For example, 5 to the power of 2 means 5 times 5. It doesn't mean 5 times 2. Okay, it means 2 5s multiplied together. 5 times 5 is 25. The first 12 square numbers are these. Now, the first square number is 1 because 1 times 1 is 1. The second square number is 4 because 2 times 2 is 4. And then 3 times 3 makes 9 and 4 times 4 makes 16. 5 times 5 makes 25 and so on up to 12 times 12, which makes 144. These are the square numbers, okay? The answers are the squares. Now, the reason they're called squares is because if you take a square that is 1 by 1 centimetre, you will get 1 centimetre squared. 1 centimetre squared. If you take a 2 by 2 centimetre square, it's 2 times 2, which makes 4 centimetres squared. If you do a 3 by 3 centimetre square, you get 9 centimetres squared, and so on. Okay, so that's why they're called square numbers, and you probably should memorise all of the square numbers up to 144, okay, because it will make your life a lot easier in the long run. Now, cube numbers are similar, but these are whole numbers that are raised to the power of 3. For example, 5 cubed is 5 times 5 times 5. It is not 5 times 3, it is 3 5s multiplied together. 5 times 5 times 5. 125. So the first few cube numbers, which I would recommend that you learn, I would recommend that you would at least learn up to 5 times 5 times 5, which is 125. Okay. So 1 times 1 times 1 gives you 1. 2 times 2 times 2 gives you 8. 3 times 3 times 3 gives you 27. 4 times 4 times 4 gives you 64. And 5 times 5 times 5 gives you 125. You could learn this one as well if you want to, and you should definitely know this one because 10 times 10 times 10 is 1000. Now, the reason they're called cube numbers is because if you take a 1 by 1 by 1 centimetre cube, you end up with 1 centimetre cubed if you multiply them together. If you had a cube that was 2 by 2 by 2 centimetres, that gives you 2 times 2 times 2, giving you 8 centimetres cubed. And the same if you had a 3 by 3 by 3, it would give you 27 centimetres cubed. And 4 times 4 times 4 would give you 64 centimetres cubed, and so on and so forth. Okay, so you just must remember that a cubed is multiplied by itself 3 times, not times by 3. Now, this is the square root sign. So the square root sign is like saying the opposite of the square. So calculating square root is the inverse, the opposite of squaring. Every number has 2 square roots. One is positive and one is negative. And we're very used to dealing with the positive answer because it's the most obvious answer. So for example, find the square root of 25. Well, we know that the square root of 25 is 5, but it can also be minus 5. Since 5 squared is 25, and minus 5 squared is also 25. Remember when we looked at our negative numbers, minus 5 times minus 5 is the same as, like, it's 2 negatives. So 2 negatives give us a positive answer. So the square root of 25 can be 5 or minus 5. Okay, so that's very important to remember. Okay, that's all for today. So I hope you understood most of that. I think, we went through a lot there. So have a practice using the assignment questions, and hopefully you've been able to write numbers in order using place value. Hate that colour. Add, subtract, multiply and divide negative numbers and some positive numbers, but we've mainly looked at negative number in this case. You've been able to read, write, order and compare positive and negative numbers, as well as having a quick look at square numbers and cube numbers, okay? So we don't need to know these in too much detail, but you do need to know what they are and you need to know the basics, all right? So revise those, watch the video as many times as possible, okay? And I look forward to seeing how you do on your assignments.